They released a verdict. No dramatic press conference. No warning. No staged moment of excitement. Just a quiet upload, a series of FITS files, photometric readings, astrometric positions, timestamped data streams slipping into national archives like routine paperwork. But the scientists who opened those files didn't see routine. They saw confirmation. Confirmation of the one scenario astronomers across the West hoped they'd never face. Because China's observations of 3I Atlas, recorded during a 36-hour blackout in Western astronomy, don't just fill a gap. They rewrite the timeline. They show an interstellar object brightening when it shouldn't, expanding its coma in ways that break our models, developing a tail structure that contradicts earlier readings, and behaving with a precision no natural comet should display. And the strangest part? Nothing about the object changed. And yet, everything did. As if it wasn't waiting for the sun. It was waiting for us. Waiting for that gap. Waiting for the moment only one nation would be watching. The timeline is everything. And the timeline is wrong. On July 1, 2025, Chile's Atlas survey detected what would become known as 3I Atlas, only the third confirmed interstellar visitor ever recorded. But something felt off immediately. It wasn't just fast. It was too fast. Moving at nearly 209,000 kilometers per hour on a trajectory that didn't belong to our solar system. Observatories across the West, Hubble, JWST, VLT, Gemini, aligned to track it continuously. And then, at the most critical moment, everything went dark. 36 hours. 5 major observatories offline. Maintenance. Calibration. Realignment. All at once. And in that narrow window, as the object approached peak solar interaction, it slipped into the sun's glare. The exact moment when comets reveal their true nature. A natural comet would have nothing to hide. An unnatural one would reveal everything. The West closed its eyes. China didn't. High-altitude observatories in Tibet, Qinghai, and Yunnan remained active. Stable skies. Continuous tracking. While others went offline, China captured everything: astrometric positions, coma expansion, tail formation, brightness curves. Every frame time-stamped. Every second accounted for. And what they saw changed everything. The coma expanded toward the sun. The tail elongated at an unnatural rate. The brightness increased rapidly, 0.3 magnitudes in hours. The dust profile shifted toward large carbon-rich grains. This wasn't normal comet behavior. This was structure. To understand why that matters, you need to understand a comet's coma, the cloud of gas and dust released as it heats up. But this object didn't just heat up. It reacted. Earlier observations had already hinted at something unusual: a carbon dioxide-dominated coma instead of water. But during the blackout, China observed something more: a brightness surge. An expansion wave. A structural reorganization of the dust cloud. Not random sublimation. A pattern. And patterns require continuous observation. China had it. The West didn't. When Western observatories came back online, the data was broken. The object had already moved millions of kilometers. But China's data stitched the missing time into a continuous sequence. And the conclusion was unavoidable. This object wasn't behaving like a comet trying to survive the sun. It was behaving like something responding to it. What China captured wasn't just data. It was the missing moment. A complete photometric sequence during peak solar activation. The results showed coma elongation toward the sun. Brightness changes consistent with controlled jet activity. Dust ratios incompatible with standard sublimation. A nucleus too small to produce the observed effects. And orbital precision that reduced uncertainty dramatically. This wasn't just good observation. It was decisive. When global scientists merged the datasets, the picture became clear and unsettling. A carbon dioxide-dominant object behaving unlike any known comet. A brightness curve that defies thermal models. A tail that changed during the exact blackout window. A response to sunlight that looked less like melting and more like activation. Not random. Not chaotic. Coherent. No one is claiming alien technology. The data doesn't say that. But it does say something else. This object behaved differently when fewer people were watching. It changed during the gap. It revealed structure in silence. And then returned to something familiar once observation resumed. The fear was never impact. The fear was intent. Not necessarily intelligent. Not necessarily artificial. But not passive. Because comets don't behave selectively. They don't wait for observational gaps. They don't change structure only when data disappears. What we're looking at may not be just an object. It may be a system. One that responds. One that adapts. One that doesn't reveal everything.